privileged to be speaking at the conference today. So what I'll be talking about would sort of capture two sides of what I do. Naira mentioned I'm the current president of the Operational Research Society, and my day job is Data and AI Director for BT. So I will share a bit of my journey to date, just some examples of applications that have been developed using AI and computational models. And then the second part of the talk will focus on effectively my reflections, okay, on what needs to be done, and also some thinking on more objectives around my term as president of the Operational Research Society. So my career to date has been using AI computational models to effect transformational change. I've spent about 24 years or so within BT, and some of these applications will come to life. And there are three key areas that we would want to focus on. And this is being driven by the need to optimize resources and deliver better service outcomes. Okay. BT is a very resource-rich organization. We have field engineering teams around 30,000, so second largest fleet operator in the UK. When it comes to energy, we consume about 0.7% of UK's electricity, and deliver services across the UK. And our ambition is to make sure that we do this optimally, meet our obligations, and also in a sustainable way. So I will be sharing some of the work that has been done to date. So goals, very much, how do we realize zero-touch operations? And we have been using AI and OR technologies to help in this regard. And then the second, it's the area of transforming our cost base whilst maximizing service outcome. And of course, at the end of the day, we depend on our teams to effect change. So the question is, how do we go about empowering our operational teams to maximize the outcomes when it comes to decision making? So these are the three objectives that we have. And what has been done to date is to build a set of capabilities to help achieve this goal. So, sorry, let me just, we start at the top with applications, because that is what is consumed by our business. And then we do have tools. Data is a key thing, ensuring that we have the right data in place to support decision making and modeling, making sure that we embed all the standards, ethics to drive the right outcomes, skills, training, enabling our teams to be upskilled to use the tools and the models that are built. And then, of course, work very closely with partners. We do have engagements with about 40 or so universities, partner with them to make sure that we are leveraging the latest thinking within the field of AI and operational research. So some examples of where we have been applying AI, and we have been using AI for a number of years. Actually, what most people don't know is that BT is the #1 patent filer for AI in the UK. Okay. And the areas that we cover include field services. I mentioned that earlier on. So we built our network, so the fiber network at the moment, that's our focus. Build the mobile network, 5G. We provision services over these networks and maintain them. Um, and then also when things break, fix them. So these are the type of activities that our engineering teams focus on. We use AI to help us immensely in that space. Okay, so this was way back in the early 90s. So scheduling was one area that we focused on using AI to ensure that we are optimizing the way we utilize our field engineering teams to deliver better service outcomes, okay, for our customers. Smart energy management. So yeah, we consume just shy of 1% of UK's electricity. And one of our key objectives is how do we go about ensuring that we optimize our energy usage across the group. Part of it is due to legacy equipment. So again, what we have been looking at is how we can use constraints modeling in this particular instance to help decommission our legacy network. And we are seeing lots of improvements in that space. Cyber security being a key national infrastructure in terms of what we have. We have developed AI models to help prevent, detect threats, cyber threats. Okay, and these are tools that have been deployed in operations, and we empower our teams, our security teams, using closed loop automation as well to be able to detect what is going on within our network. A few years ago, we deployed AI models, again, using machine learning techniques to detect nuisance calls. These are embedded, again, in our handsets. So being able to detect and block nuisance calls there. Predicting customer journeys key to ensure that we deliver the outcomes that we have agreed with our customers, and the ability to predict when things may fail. It's a key part of what we do. And I will show some examples later on. To roll out fiber, again, massive constraints, modeling exercise, and we're using both that and optimization to ensure that fiber is properly rolled out across the country. And then, of course, we are a very old and established company, different generations of data and network data, inventory data in that instance. And what we are doing is use AI to help with improving the quality of our inventory. Okay, so some work along those lines to help with diagnostics. So being able to detect faults within our networks, and in some instances, forecasting fault intake that will come our way to give us the visibility of demand so that we can optimally deploy our engineers. And more recently, we've been looking at productivity of our software engineering community. Everything is now software. All that we do, it's software based. We have quite a lot of software engineers within the team. We use third-party vendors as well. One of our challenges is how do you ensure that we can use AI to help in the engineering process, either with test generation or even enhancing the quality of our code. So these are some examples of the use of AI within the company. And most of these initiatives are approached through the lens of transformation, because it's not just the technology per se, but we want to make sure we can embed whatever it's done in a sustainable way. So it's looked at, first of all, the processes that underpin the operations, look at the impact on the people, and then work with the teams who are appropriate to land the outcomes that we deserve. So I'll put this up just to illustrate. Typically, we will have process diagrams that look like this: perfect swim lanes, But what tends to happen in practice is this. So you have workarounds and just to get things done. And our starting point, it's how do we detect opportunities within our processes? Where are the gaps and how do you go about addressing them? Then we start modeling and work with the operational teams to embed those models. Okay, so this will be an example of a process where we use process mining techniques to highlight these opportunities that would then lead to the modeling exercise. And I'll touch on a few examples of what has been embedded within the business. So I mentioned the field engineers. So as an example, here we do have what we call patches. So the areas are the patches. The squares are the field engineers. So field engineers will be assigned to a patch and they'll be given jobs within that patch. One for managerial reasons, and also to help, in some cases, improve productivity. But what tends to happen, and in this case that I'm showing here, is that we have this engineer who is positioned near a neighboring patch. Ideally, it will be better to have that engineer pick up work in the neighboring patch if that will make him or her more productive. Current systems, for computational reasons, don't allow that. Okay, so what we did a few years ago was to use fuzzy logic to relax these hard constraints with a view of maximizing the way we utilize the engineers. Okay, and then rebuild those boundaries, as it were. They are just logical once we have utilized the engineer, and that is required again from a managerial constraint point of view. And what this led to, it's of course productivity went up. We're able to deliver more jobs over the year. I think in this instance around 400,000 at a point in time a year, and fulfillment for the engineers as well. Okay, so using AI to help make sure that we get the outcomes that we desire, whilst empowering our engineers. Another example is around shift patterns. So we do have a number of shift patterns allow engineers either to work 4-day week, 5-day week, different start times, just to accommodate their personal circumstances. But what this leads to is that there are many variations of patterns, and the challenge is how do we ensure that we have enough people on the ground on any given day to deliver work. So what, again, in this instance, work with one of our university partners, and what we did was apply some AI techniques to model new roster patterns. Okay, so case in point, what we are seeing here is that we had on any given Monday between 112 and 123 engineers. Okay, and then on a Saturday, for example, 19 and 38. Of course, if we have 19 people there, enough work for them, making sure that we don't fail any SLAs, that is great. Yeah. But what happens is if you have 19 more work that may lead to failing SLAs, then that is a problem. So what we did was applying those models, came up with a new optimal set of shift patterns, which will ensure that we have the right mix of people on any given day to deliver work. So our engineers are multi-skilled. They have varying attendance patterns, as I've highlighted. And they also have, preferences in some cases for where they work. And taking those constraints into account, taking the constraints around the customer into account, and what the company wants to achieve forms the basis of our modeling exercise. And this, again, the multi-scaling approach is a scale problem. If you're doing this across tens of thousands of engineers with very high volume of demand coming our way, we have built a framework to allow us to undertake this exercise. And the way we do this is to apply a number of models. So for us, yeah, the goal is to make sure that we have the right engineer at the right time doing the right job. That is the objective. Okay, and we want to make sure that we minimize travel time, minimizing a risk of failure, and then bundle as many jobs as we can for the engineers with a view that when they are in a particular area or visit an exchange, we maximize their utilization. Okay, so that it's how we go about modeling that. And there is a two-stage approach, especially within the scheduling space, where we generate a full schedule at the start of day, and then build some sort of, there is a recommendation part for some of our work streams. And this is to empower the engineers, because it's getting the balance right between giving them one job at a time to the engineer and then empowering the engineering community so that when they visit a site, if there is any job around them that they believe needs attending to, they will do that. Okay, so that's sort of empowerment, and that's why we also augment the scheduling with a recommendation. So they pick another one or recommend a job to one of their colleagues. And part of the coming up with those recommendations, in terms of the list of jobs, we use fuzzy logic with task prioritization there. I'll quickly show a video of one of the capabilities that have been built. So what we see here, again, patches, and the objective here is how do you go about reconstructing these patches with a view of maximizing the way we utilize our engineers. And this, it's key when new services have been, or products and services have been delivered. We want to understand the implication on the current structure, or where we have hired new people to join us. What does that mean? So I'll just play this video for us to see what it looks like. So we start off by showing of course, the objectives, look at the current state. So the green, perfect match between supply and demand in terms of skills, resources, and then highlights those areas that need attention. Okay, and these are the objectives that we are looking at. In this instance, we're using an evolutionary technique, and we run that through a number of times, use historical data to help us with this exercise. So historic demand profile, we could also superimpose that with forecast of demand that may come our way. And we run this through a number of iterations, work with the operational teams because they know the locations best to fine tune, okay, what has been produced here. So that red patch was cleared, and then provide, of course, stats on the outcomes, look at any skills, demand gaps if there is any need for the operational users to tweak them, they can do that. And then they have the ability to override some of the outputs that have been generated, combine certain patches, and so on. And yeah, well, in this particular instance, we saw an improvement in our CO2 or reduction in our CO2 emissions. And also because the engineers were properly positioned, they were able to honor our commitments. Yeah. This is another example where we want to know where best to deploy our equipment. Okay, so we do have a number of equipment across the organization. We want to minimize travel because that is waste. So again, using historic data, where appropriate, inject forecasts, we can input the number of areas, and then the tool will look at the best clusters as to where we should deploy these equipment. Okay, so that it's what we see here. Again, this capability led to reduction in travel time, which leads to more jobs being done, and also improves the productivity of our engineering teams. Yeah. Another example is we want to understand what happened on the day. So our engineers do have jobs assigned to them. We want to know what happened. So once the schedule has been, this is post a bit of looking at the history. For example, they are meant to work within certain areas. Is that happening? Are they moving out? Is it because they had to travel to get spares from another location? And we use all these insights to help us optimize our schedules going forward. So this is a typical journey of an engineer. We highlight those hotspots, and then we can also simulate what happened on the day. So we can see the engineers traveling on those days. Yeah. One of the areas that we are looking at, I mean, before explainability became a hot topic, we had to explain what we have developed to our operational teams. And I remember very early on in my career, we had these heuristic methods that were used. And each time we presented a schedule, there was a different configuration. And that didn't go down well with our operational teams. They wanted that assurance and certainty. So we needed to find a way to expose what was going on within the models. And we built this framework to allow us to communicate what was going on within the models and to our operational teams, but also give them the chance to scenario model and move things around where appropriate. So we have different algorithms here that can be used in terms of the objectives. We could model that as well, and yeah, they can inject more jobs. What does that mean to the schedule? They can then look at different resource profiles where appropriate, and so on. This led to engendering confidence in the models that we had developed, and of course we learned from that. And since then, whatever model we build, we look at it through that lens. How would we go about explaining what is going on to the operational users? Yeah. More recently, we have been looking at building federated models, and for us, it's about a digital twin of our network. So the examples I showed earlier on were point solutions, and we want to look at how we can do that at scale, and using the framework of digital twins allows us to do that. So this means that we need to have access to clean data sets, okay, and then have the modeling, the AI bit, look at the use cases that are consumed, and federated digital twins. I mentioned the different, the mobile network, the access network, and so on. How do we go about building a federated digital twins? And even in some cases, work with other companies. A year or so ago, we worked with Anglia Water and the UK Power Networks to look at how utilities like ourselves could respond to impact of climate change on our networks. Okay, so how do you go about working with them along those lines? And again, a number of capabilities and technologies underpinning this. But one of the things that we have been focusing on is making sure that the data is right. But at the end of the day, good models require good quality data. So we spend quite a lot of effort ensuring that we have those artifacts well defined. And in terms of our journey to date, we do have areas that we are still evolving, but others quite matured. So within the energy space, we have a good view of what is across our estate, modeling that, understanding how best we can manage capacity within our network. Other areas that are still in flight, looking at how we can optimize in-building design, and also knowledge management. So we do have, part of our engineering community who will be retiring soon. How do we make sure that we capture that knowledge properly? And then finally, quite recent area of focus for us is some modeling within our exchanges. So a quick view on how we are using AI to detect and correct inventory. So within pole discovery, we have poles all across the country, understanding the quality of the poles, understanding where they are at. So this is using some machine learning techniques to help in that regard. Rolling out fiber requires us to be able to ensure that we can predict blockages within our ducts, also understand tree coverage that impacts area view, and then what is within our cabinets. So some reflections. I have about 10 minutes or so to go, and I'll open up for questions. So just a quick one. 1.8, simulation and prototyping, I touched on this earlier on, helps us to validate user requirements and scenarios, okay? And help us to engage our stakeholder better. Data, I touched on that. Trials, quick proof of value demonstrators help us to identify gaps within the data, and also to get the operational teams to understand what they need to do to fix those. And it's all done before any national rollout. And visualization, it's a key one. Simulation, for example, gives us insight into behaviors. One of the earlier demos that I showed, all these help us, okay, and the operational teams to ensure that we can better communicate our transformational outcomes. And another observation, it's good to develop proof of value demonstrators, but the key thing is, how do you go about doing this at scale in terms of capturing the data? How do we change mindsets when it comes to working with data, and also articulating benefits for any transformation program to scale? We need a way to articulate the benefits. So these are some concerns that need to be addressed to properly embed what we have developed. Not everything that counts can be counted, and not everything that can be counted, counts. Okay, and this is a quote that reflects the need to have both soft and hard OR to effect transformational change. So for us to be able to do this properly, we have to reflect those. So there's a key lesson for me as part of my career. It's not just the computational mathematical models, but also incorporating the softer aspects of operations. Okay, we need to think along these lines to be able to get the right outcomes that we desire. And of course, Albert Einstein said we should learn from yesterday, live for today, hope for tomorrow. And for me, of course, that corporate memory key, ensuring that we don't reinvent the wheel. Others have done it. Let's leverage that as much as possible. And then keep questioning. The fact that things have been done a particular way doesn't mean that we stick with that. And then, of course, at the end of the day, as a modeling community, ensuring that we are visible, because if we don't let the operational teams know what we have, then they will miss out on the capabilities that we are developing to improve decision making. So all this really part of what the OR Society does, and that's about the science of better decision making. The examples I showed is in line with our objective. I mean, this year is the 75th anniversary of the OR Society, and want to take this year of celebration to celebrate the past, reflect on what we are doing, and then, of course, chart the course for the next phase of our journey. And part of what we are doing is kicked off a campaign tagged "This is OR" to shine the light on operational research methodologies, tools to help with better decision making. So you will be seeing more of this as the year goes on. And for us, it's making sure that the breadth of the capabilities available to us, both the hard side of OR and the soft side, are utilized effectively when we are making decisions within organizations. And AI has been a key part of the journey to date. We are seeing a lot of focus on that. I have used AI. My PhD was in AI many years ago. I just want to flag a few observations. Of course, this is changing the way we work. I've spent the past year or so just understanding the impact of some of the initiatives around Gen AI will have on our operations. It impacts the environment we work in. Okay, it impacts education, and we need to look at how best to make sure that we get the outcomes, the desired outcomes for all of us. So just a few stats. IDC predicts the compound annual growth for global spending on AI will be 46% by 2023. Okay, PwC suggests AI would add 15.7 trillion to the global economy. World Economic Forum, they also predict by 2025, machines and algorithms will perform more current tasks than human, and so on. So this is impacting us and will impact us going forward. How do we make sure that we respond to this effectively? And I'll just finish by saying that my main concern is, first of all, with a focus on AI, the question is, are we losing out, if you talk about education, on exposing students to the breadth of tools for decision making. We do understand that universities are closing down or rebranding, let me put it that way, rebranding OR departments as AI, data science, whatever it is. Yeah. And by doing that, I think, are we going to educate students or the future skill sets for the country that it's very narrow? Okay, and I'll just finish with an example. There was a job that was given to some machine learning teams, and they were asked to fix a particular compaction problem. And they asked, where is the data? They were given a year's worth of data. And they said, this is not enough. We need more data. But what they failed to realize was that it wasn't a machine learning problem. It was a constraint optimization problem. Okay. And my concern is ensuring that the students we bring out of our universities don't see problems through the lens of just machine learning, but approach it through the breadth of capabilities that computational mathematical models have to offer. Thank you.